Okay, this is the video on tolerancing, and you watched a YouTube video what tolerance is all about. Just in case you need some work on it, here we go. So I'm going to step through this book with you step by step. So if you have any questions, hopefully I'll be able to answer them through this video. First of all, you have to understand what a tolerance is. It's the total amount of size variation. So in this case, this one is it's plus or minus, so that's an equal bilateral from the basic size. Again, understand what basic size is. It's in this case it's a half inch or 0.5. So from that basic size, you can go plus or minus a standard amount, whatever the tolerance calls out for. So if you add, so you could have 0.51, 0.49. Okay, if you want to put it in the limit form, that's a limit form because you take the basic, add the tolerance, subtract the tolerance, and so that's the total variation in size. Again, limits. Okay, the limits of the tolerance are the largest and smallest the part can be. So it's I look at it as the ceiling and the floor of the size. So if you take your size and you add and subtract the tolerance, you get 0.51 and you get 0.49. A lot of times if you're making a part, I like to see it versus this because I see if I had 0.51, 0.49 as the value for my dimensions in there. Okay, and that's my value. As a machinist, I can see, okay, I can hit 0.51 and I'm there. I can go down to 0.49 and I'm still within. Okay, the middle, the mean would be right here in the middle between those two. See, if I'm machining, the part would be thicker, probably, and then you're machining material off, so the first dimension you're going to get to is the 0.51. So usually, I mean, it's not there's no ANSI standard for that, but it's usually a common practice to put whatever dimension you're going to hit first, you put on top, and whatever dimension you hit second, you put underneath. So a lot of the machining manufacturer people like it that way. All right, I want you to understand what bilateral, okay, there's equal bilateral and there's unequal bilateral. So let's say you go 0.500 plus 0.001 minus 0.005. Yeah, that's a bilateral tolerance, but it's unequal bilateral. Can you make it a limit form? Yeah, you take 0.5 and you add 1, so you got 0.501. You take 0.5, subtract, you got 0.495. So you can take this unequal bilateral and turn it into a limit. All right. Now the unilateral, which is one under here, the unilateral, again, a unicycle has one wheel, so it can only go one way. So if I take that 0.500, let's add 0.005 and subtract 0.000. And notice how I write them. If you look at here, there's only a 2-place dimension, and they got 2-place in their tolerance. Here I'm putting 3-place in my basic size, and I got to put 3-place in my tolerance. So if you had a 4-place here, you want to put 4-place in your tolerance. So if I take this, I take 0.5, add 5, you get 0.505. If you take this, subtract nothing, you get 0.500. So there it is in limit form. There it is in unidirectional or unilateral form. And then here is bilateral, but it's unequal bilateral. All right, you need to understand what MMC stands for. So let's look at, and the symbol for that is an M with a circle around it. Now the opposite of MMC is known as least, L-E-A, least material condition. All right, L-M-C, and that is an L with a circle around it. You need to know these two. All right, let's look at the situation. Here's a bolt, okay, something with an outside diameter. It has a size, okay, a limit size, 2489, 2408. What is the biggest size? Which is this one. So that is the MMC of that bolt. Another way to look at the bolt is which bolt weighs more. Right? The larger diameter will weigh more because it has more material. The one with least material, that one, since it's got least material, it weighs less. Let's look at the MMC. This is a shaft. This here is a hole. Okay, it's a hole. What is the MMC? Well, if you look at it, what diameter contains more material in the part? Well, the 255 is the M, and the 260 is the L. Okay, so if you look at a plate of steel, let's look at it in the top view. You got two plates that are identical, and you put a hole in one and a hole in the other. Which part has more material? Well, it'd be this one is the MMC concept because it has more material. It weighs more. This one's got a huge hole in it. It weighs less. So this would be the least material condition. So the smaller the hole, the more material. The bigger the hole, the less material. All right, we're going to look at different types of fits here. This here is a clearance fit. And what we have to do is basically take the MMC of each and then see how they fit. So if you're making thousands of these parts on a machine, CNC machine, and this is the tolerance, it's it could be written 500 plus 0.002 minus 0.000. That would give you the same result as this. This shows you in a limit form. There is a unilateral, lateral, or you can make it unequal bilateral, whatever you want to do. So the MMC of that is 502. All right, there's the M. The least material condition would be the smaller the shaft. That's an L. Now let's go over here to the hole. What is the max material condition? It would be the smaller. So there is the M. The largest hole would be the L. And what you need to do is draw a line from M to M, connect the M's together, and look at it. The shaft at its biggest size is 502. The hole at its smallest size is 503. So it has how much clearance? 1,000. So it's got 0.001 clearance. And if you look at the least material condition, the smallest the shaft and the smallest or the biggest the hole, okay, and if you put the L's together with a line, you get 500 here, 505, so that's 5,000 slop. Okay, that's a loose fit. Okay, we'll call it slop. And the 001 would be called allowance. Okay, understand that term allowance. Allowance is the tightest possible fit, but yet there's still clearance. This is a positive allowance because it's a clearance fit. Okay, so that's what a clearance fit. No matter what size the parts are, they will fit with some clearance. Now, if you look at interference fit, it's just the opposite. No matter what size the shafts are, or the pieces going together, it doesn't have to be a shaft and a hole, it could be a fork and a tongue. No matter what they are, they're going to have to use a hammer or some type of mechanical press to put the parts together. Sometimes they're heated in ovens, put in dry ice or liquid nitrogen to shrink one, heat the other one up. So there's a lot of different ways to do it. So let's look at this. The MMC is here. The LMC is there. The MMC is here. The LMC is there. All right, make sure you get that. Take a shaft, just put the M's together. So the shaft is 5,000ths, 0.005. All right, that is the allowance. Now that's the allowance, but it's a negative allowance because Negative allowance is at an interference fit. See? And allowance is always at the MMC, never at the LMC. So always at the MMC, you get your allowance, which is -5. What is the slot? Well, the loosest about a fit here would be, that is 498, 497, so it goes from a thousandths press. All right, still a press fit, no matter what size the parts are made at. Here's a thousandths press at LMC and 5,000ths press at MMC, and that's your allowance or negative allowance. On this page here in your book, they talk about allowance, so and maximum clearance, so loosest fit. I call it the sloppiest fit, however you want to call it. So make sure you understand that. Let's do one of these problems here. Let's do this problem here. All right, below you'll see a shaft and a collar. Here's the shaft, here's the collar. The basic dimension of the shaft is 500, so we know that's let me get more lead here, 0.5000. And I'm going to go to 4 place because I see there's a 4 place here. Dimension completely as follows. Apply a tolerance of 4/10 or plus or minus 2 to the shaft. So if I add or subtract 0.0002, I get 0.5002, 0.4998. Okay, there I'm in bilateral, there I'm in limit form. All right, here they show the dimensions with limits. So my format is going to have to be in the limit form. And notice the diameter symbol. Anytime you got something round or a hole, you got to have the diameter symbol. Okay, apply a tolerance of I think we did that. And a thousandths tolerance to the collar. Well, I don't know what to put a thousandths on yet. It says provide an allowance of 2/10. So 2/10 is always at MMC, or the allowance is always at MMC. So if I make this an M and this an L, right, because there's the maximum size. So the allowance, see, this is a clearance fit. The allowance would be the tightest possible fit, but yet still clearance. So over here, my hole would start at 0.5004, because that is 2/10 bigger than that. That would be the MMC. Put my diameter symbol. And then what is the other one? Well, they say provide a thousandths tolerance to the collar. So just make the hole bigger, so it'd be 0.5014, and that would be the LMC condition. So there's your result. Okay, I provided an allowance of 2/10 because MMC to MMC gives me 2/10 clearance, and then it says a thousandths tolerance to the collar, or there's a thousandths tolerance right there. Okay, so that's it for the. The next video is going to show you how to use the charting for the other type of fit. So over and out.